Okay, I really don't know what to give as an intro to this video, so I'm just going to give that statement as intro to this video. So this for Renax on TikTok. Um, I hope you learned something from it. The first question, the question says that in the diagram shows a circle with radius of x, radius of r centimeter, and two regular hexagons. Each side of the larger hexagon A, B, C, D, E, and F is a tangent to the circle, and each side of the smaller hexagon P, Q, R, S, T, U is a chord to the circle. By considering perimeter, show that 3 is less than pi, less than 2 root 3. The first thing, since this polygon, that is the smaller hexagon, is inscribed inside the circle, then the perimeter of that hexagon would be less than, let me write it here, the perimeter of the smaller, of the less than equal to sign, less than hexagon, let me call it as H. The perimeter of the smaller hexagon should be less than the perimeter of the circle, or rather circumference. Perimeter of circle is circumference. And that perimeter of the circle should also be less than the perimeter of the larger hexagon, because that larger hexagon will cover more distance than the circle that is drawn inside it. So the perimeter of the smaller hexagon is less than the perimeter of the circle, and that is also less than the perimeter of the larger hexagon. Good. So with this finding, we need to first of all find the perimeter of the smaller hexagon, then find the perimeter of the circle, then find the perimeter of the larger hexagon. The perimeter of the circle is given as circumference, and the circumference of the circle is known as 2 times pi times radius. The radius is given as r, so I put it as r. So now all we need to find is the perimeter of the smaller hexagon and the perimeter of the larger hexagon. To find the perimeter of the shape is simply just the addition of each side of that shape. So this shape has 6 sides with the same length. The length is the same because it was given inside the question as a regular hexagon. So each side has the same length. So basically, what we're going to look for, we're looking for the perimeter of the smaller hexagon. We're looking for the perimeter of the smaller hexagon. It should be 6 times the length ut, and the perimeter of the larger hexagon should also be 6 times the length, EF. So 6 times ut will give you the perimeter of the smaller hexagon, and 6 times EF will give you the perimeter of the larger hexagon. So now all we need to find is the distance ut and the distance EF. Let O be the center of the circle. Then since the 2 hexagons are inscribed around that circle, then O would also be the center of the smaller hexagon and the larger hexagon. If we draw 2 lines from the point U and T to meet at O, a triangle will be formed, and this triangle will be this triangle will be an equilateral triangle. As an equilateral triangle, because we know that the theta of sector here will be theta, and this theta will be the same theta that will be here, will be the same theta that will be here, same here and same here. So eventually you have 6 theta to equal to the sum of angles at the point, and the sum of angles at the point is already known as 360. So this theta will equal to 360 divided by 6, which is equal to 60 degrees. And since the radius here is the same radius here, this will also be an isosceles triangle. And to get the base angle of an isosceles triangle is equal to 180 minus the top angle divided by 2. 180 minus 60 is 120 divided by 2 is equal to 60 here. The angle here will be the same angle here, which means that all sides or all angles will be 60, 60, 60. That's an equilateral triangle. So for an equilateral triangle, we know that the length of one side will be the same as the length of all sides. So if this is radius r, then the length TU would also be r. So we have here 6r is less than 2 pi r. Now let's find the upper bound. That is finding the length EF. To get the length EF, we need to draw another triangle. Let me clean the inner diagonal that I average. We need to draw another triangle. And this second triangle we're drawing should meet here at this point here to the center O. We know this distance will still be radius because this circle touches the side EF at this point. And any point drawn from the circle or from circumference to the center has a radius or have a length of r, which is radius. If you draw another line from E to O, then we will get a right angle triangle. So this angle here will be 90 degrees, while here will be 30 degrees. Because remember, the angle go from here to here was 60 degrees. Half of that will give you 30 degrees here. And since here is 30 degrees and here is 90 degrees, what's left of a triangle should be 60 degrees. So you have a right angle triangle, 30 degrees, 60 degrees, and 90 degrees. The height is r, while the hypotenuse, we don't need that, but the other side is half of EF. From SOHCAHTOA, we see that tan 30 degrees is going to equal to the opposite, which is half EF, divided by the adjacent, which is the radius r. Multiply both sides by r, we have that r times tan 30 is equal to half times the distance EF. Multiply both sides by 2, we have 2r tan 30 is equal to EF. Tan 30 is equal to root 3 divided by 3 times 2r, we have that EF is equal to 2r times root 3 over 3. If we put that in our expression, we have EF, 6 times EF will equal to 6 times 2r root 3 divided by 3. Good. What they asked us to prove was in terms of pi and not 2 pi r. So you have to divide both sides by 2r. 6r divided by 2r is 3, which is less than 2 pi r divided by 2r is 5, which is less than 6 times 2r root 3 over 3 divided by 2r will be 6 times root 3 over 3. 3 here 2, 3 here 1. So all you are left with is 3 is less than pi less than 2 root 3. And this was what they asked us to show. So using the perimeters of the circle and the two regular hexagons, we're proving that 3 is less than pi, which is also less than 2 root 3. This is the second question. I don't know, I'm not excited with solving this thing. But this question says we should find the area of this shape. Find the area of this shape. And the area of this shape, right, if you complete this square, then the area of this shape, the area of that complex shape, that A of C, is going to equal to the area of the square plus 4 times the area of the triangle. That is, we have the area of this square here plus 4 times the area of this triangle. So if we have the length of the square, we can find the area. And if we have the basically you can find the area of this triangle because this is going to give you 90 degrees. It's 90 degrees because if you have the exterior angle of an octagon, the angle of an octagon will be 260 divided by 8. 260 divided by 8 will give you, I think it is 45. 45. Yeah, this is 45. So the angle here is 45 plus the other angle here is 45. This is the top 90 degree. Okay. So this is that. Let's find our area of triangle first of all. Area of triangle. So if we know that, let me redraw that triangle. This is that triangle that's up here. The angle here is 90 degree, and the length here is A, the length is A. Because the question said each octagon has a side length of A. So the length here is A, the length here is A. Good. The area of a right angle triangle is basically just half times base, or the area of any triangle is half times base times height. The base is E, the height is A. So the area of this triangle will be half times A times E is equal to half A squared. Good. The second part of it is we need this blue length, that is this dotted length here. We need this blue length to complete this square, because we already have length here is E, length here is E. But we need total length, which includes this blue length. So let's find this blue length from Pythagorean theorem. Pythagorean theorem says that, no one says it, but basically that blue length squared is equal to A squared plus A squared. So B squared should equal to 2A squared. You square both sides, and that blue length is equal to the square root of 2A squared, which is equal to A root 2. Good. So we can progress. If we know that the area of this triangle is half A squared, then 4 times the area of that triangle will be 2A squared. So we can remove 4 times the area of the triangle and just put 2A squared. Now let's find the area of the square. The area of the square is L square, and the length is A plus A plus A root 2. This whole length is equal to this length plus this length plus this length. The first length is A, the second length is A root 2, and the third length is A. So the total length L will be equal to 2A plus A root 2. The area of a square is equal to length square. So A plus 2. So the area of this square is going to equal to 2A plus A root 2 all squared, which is equal to 2A plus A root 2 all squared, which is equal to 4A squared plus 4A square root 2. 2 times 2, that's 4. A times A, that's A squared, times 2, 4 times plus 4A square root 2 plus 2A squared. Don't forget, this is the area of square. We need to add this area, the 4 times area of that triangle that we just got here. So we are adding plus 2A squared again. So now this is our area of the complex shape as A of C. This is our area of the complex shape, and if we simplify, we have 4A squared here plus 2A squared plus 3A squared. That is 8A squared plus 4A squared and 2. If we factor out A squared, we are going to have 8 plus 4 root 2 times A squared. If we factor out 4, we are going to have 4 times 2 plus root 2 times A squared. And if you can see, this is now in the form that was given in the question. The question says P times 2 plus root 2 times A squared. And here we have 4 times 2 plus root 2 times A squared. So our P basically just equal to 4. But they didn't ask us to find P, they just told us to put it in this form. So this is your answer: 4 times 2 plus root 2 A squared unit square. Don't forget your units. They not tell us the unit, so unit square. Let's move on to the next question. This question, I forgot to write the question now, but we're going to say something about lamps. Lamp A flashes every 20 seconds, lamp B flashes every 5 seconds, and lamp C flashes every 120 seconds. I think how many times do they flash at the same time in 1 hour? So let's just go find the interval. How many times or how long does it take them to flash at the same time? They all start at the same time. So this one flash every 20 seconds, one flash every 45 seconds, 45 seconds, this one flash every 1 or 10 seconds. For them to flash at the same time, right? If you get the LCA, that's the lowest common multiple of 20, 45, and 120. I'm not going to stress myself too much, but you have 20. So they flash together after 360 seconds. Okay, so after 360 seconds, A, B, and C will flash together again. The second part of the question is how many times do they flash together in 1 hour? And to get that, in 1 hour, how many times will you see 360 seconds? 1 hour is equal to 60 minutes, and 1 minute is equal to 60 seconds. 60 here 1, 60 here 6, 60 here 1, 60 here 10. So you have 10 times. So in 1 hour, A, B, and C will flash together 10 times.